Hello and welcome to this video. In this video, we are going to solve one more LLD problem that was asked in Microsoft Machine Coding Round, that is AutoComplete Engine for a IDE. So first, let's try to understand what is an AutoComplete Engine, AutoComplete feature or AutoComplete system. So when we generally use many browsers which has search functionalities. Let's take an example of Google. When we are searching something and when we try to type some prefix in it, it will try to give us suggestions. That part is called autocomplete feature. Whether we want to select that suggestion or not, that is up to us. So that is called an autocomplete feature, autocomplete engine. So now let's move to the problem statement. What was asked? So let's move to the first one. We want to design and implement the core logic for an autocomplete engine, which was used in a text editor or IDE. So our focus is going to be on designing an autocomplete feature or engine for an IDE particularly. Okay. What is the second requirement? The engine should suggest completions as the user types text based on previously stored entities or usage context. So when there are going to be multiple IDs which we all have worked on. So the most common and preferred ones are IntelliJ IDE, VS Code, Eclipse. So how their autocomplete feature works. So when let's say we are working on a project. So in our project there are going to be many classes that we are writing, many functions we are writing. So in that repository, when we try to write a function name, let's say print number. Okay. So when we try to use print number again, when we try to type print n, right? So it will try to suggest our this method in that particular repository. So that is going to be the context, usage context. If we have previously used something, then it will get stored in the autocomplete engine and then it can be given as a suggestion next time. So let's take a more easy example to understand it better. Let's say we type a prefix pri. So there can be multiple suggestions that can be provided by our autocomplete engine. So we need to suggest the top matching words or symbols. Example, print private printf. So this is going to be context. So in case of IDE, what can be context, usage context we can have? What I can understand is we can use language as a context. Language, when we say there are different languages like Java, Python, and JavaScript. C++, there can be many more, right? So we need to return, we will be considering language as a usage context, that on which language we are working. Based on that, we will try to give suggestion for that particular language. Return suggestion in sorted order based on frequency usage or relevance. So when we read this statement, return suggestion in sorted order based on frequency or relevance. So this thing will hit in mind that when we are designing our suggestion strategy, in that case we will need to design our strategy based on the frequency of the words that are used in our system or the relevance. So what does relevance means here? Let's say in our IDE we are using Java language. Okay, so Java language has predefined things in it that are called keywords. There are going to be some methods. There are going to be some classes, right? So these are going to be predefined words. So keywords are the basic building blocks of any language. So the relevance score for keyword is going to be always higher. let's say I am typing IN in my IDE, then it should give INT or integer as a suggestion, because these are the keywords in our Java language, right? So we can use two different kind of strategies. One is frequency ranking and second is relevance ranking. That is what I have mentioned here. Create strategy based on frequency of usage or relevance type. Few more points that we can discuss with the interviewer, that in an IDE, that I already mentioned, that we can have specific language that we can use as a context for suggestions. So there are going to be some methods that we need to add in our system when user search a words, right? It needs to be added in context, or it's need added in the system. That is very important, because next time then only we will get it as a suggestion. If we are not adding it, then we will not able to get any suggestion. For frequency based strategy, now we can understand, if we want to create a strategy related to frequency based, then we need to have a counter for each word that we are going to store in our autocomplete engine, right? In our system, that whenever we are using, let's say we are using print 5 times, so every time our usage counter variable will get increment. So there can be private. If we are using print multiple times and we are typing pri more than private, then print should come first as compared to private in our suggestion. Okay, that is going to be the requirement. And then before moving to the entities or implementation part, uh, to solve this question, one thing is very important. We will only able to solve autocomplete engine because we want to store each words inside our system. For that we need a data structure, and in this particular kind of scenario, there is a specific data structure that we need to use. So if you are not aware about this data structure, then we will not able to solve this problem efficiently, and this is not widely used data structure in many things. So we need to use Trie data structure to store and traverse in our system. TRIE. This is the data structure that we need to use. Okay, let me write it. So we need to understand what is Trie data structure first. Okay, if you are aware about Trie data structure, that is very good. But if you are hearing this Trie data structure first time, then please keep watching this video. Otherwise this question we will not able to solve simply by creating some entities, because this is going to be the main building block of this system. Okay, let me try to so before going to the entities and implementation part, let's try to understand how a TrieNode or Trie data structure will work. So when we say Trie, we have generally seen that there are some kind of trees that are available. One is binary tree, that has root and two children, right? 1 and 2. But to solve this kind of problem, we will not have binary tree which will have, now this can have 1 and this can have 2, this again can have 1 and this again can have 2. This is simple binary tree, right? This is not we are going to use in this case. In TrieNode, let's say let's take an example of what we have used, words, right? For pri, that is going to be print. Then one we have println and private. This is what we are we will try to build, okay, in this for Trie Data Structure. So let's say we will have a array or hash map. If we try to store each word separately, what we need to do? We need to have a separate entry for each word, print, println, private, right? That is how we can store it in array or hash map. But then there are going to be thousands or millions of words. So this strategy will not going to work. So we need to store it as it is a kind of modified tree data structure or a tree structure, where what we can do is root node will have first character of each word. Let's say for PRI we will have one P character, okay. So we will try to create a hash map, let's say TrieNode class, which will have a map character. So we are going to store everything in character. Every word should be a character, and inside that we are going to store value as TrieNode itself. We can name it children, and we can have one more variable is end of word. That can be a boolean value, okay. This is going to be our data structure that we are going to use. So it will have a flag that is end of word, okay. Let me try to change the color. This flag can either be true or false, okay. So when we are storing PRI for first word, as we have created a hash map of character and TrieNode. So first character will have two things. One is the character, that is character, and other is the address of the other tree node. So it will have the address of the R tree node, correct. Then it will have the store for I, and each node is going to have one variable is end of word or not. So for all these this PRI, still we are not able to create a word, right? So now we have reached PRI. Now it can have three words, PRI and T. Let's try to for I, let's try to have N, and then for pri we can have private. So I will have two characters pointing to it. One is N and one is V. N will have T after it, right? And then this has become PRINT, one word. So here we will mark our flag as true, is end of word, true. This will have, this will be considered a complete word. So that when we try to read this root node and try to iterate over it, and when it will reach, it can check if this flag value is true, then this is a complete word, and this word we can use it for suggestion, okay. So this is the main motive of this data structure. and now we are creating print. We can also create print ln, correct? After that we can have l, and then we can have n. This is again going to be same. Now is end of word is again going to be and true for this. Then we have one more word, print and println. Now these two are covered in the same hierarchy, right? This is extending this word, this root node. And we can have private. So we have a different branch, then it can have a t e, right? And this is going to be is end of word. So that's how we will create our root node structure. Let's take one more example, how we can insert or how we can iterate over it. Let's take one more example, like two words, HEL. If we try to type, then it will give HELLO hello and HELP, right? These are going to be two words. So when we try to iterate over it, when user gives this hello, it will look for it in the root node, whether our root node contains the first character H in it. And if we see our current root node, it only contains one character initially, that is pointing to P. So for this word we will not able to get any suggestions. So what we need to do, we can insert hello when user types it hello in it. So for that we need to create a separate root. We need to point it to separate character, that is not P, that is H, right? Or I can change the color as well. This is going to be H. Then it will point to E. It will point to L. Then it will have one P. This will create a whole word help, and then it will again point to this L root node will have pointers to again one more L, and this will point to O word. Now we need to mark end of word at this position, help and O, right? So now you might ask question that how this tree is different from the simple binary tree, right? As we are having, let's say we are having two nodes. Nowhere we have more than two nodes for each word, right? Let's take one more example to understand it clearly. Okay, that is apple. If we type app, then we will have apps and apple, right? If I try to take a new color for this, so now when it will look for A, right, it will not able to find anything. Let me try to remove this. So in root node we need to add one more character now, that is going to be A. Then it will point to P. It will again point to P. Then it will have S, right? And this will be our end of word. So as you can see, now this root node has three children. and each children will have subsequent children, right? So if we are creating a this kind of tree, that's why we are calling it trie. How many, if we are searching from A to Z, how many children at first layer it can have? It can have A to Z, right? A to Z. That is 26 characters. So root node will contains address to the 26 characters from A to Z. If we are adding any word related to B or C, let's say copy we are adding, right? So we will have one more here, C, O, P. So any word that prefix is start from cop, that is going to be double P and Y. We can also have cops, right? So it can have cops. This is for autocomplete IDE that I am telling you. That's how. So what operations we are doing here is, first we are adding a word and then we are searching, and also we are marking each when a complete word is formed, if the end of word is true or not, if this whole hierarchy from the beginning can be considered as a word or not. Let's say from print, print. So one path from the root can be considered as word or not. Let's say pr, then here we have v a private, right? So this is how tree data structure is going to work. I hope this makes sense. So this when we try to create a trie node, we will have some functions in it. One is going to be insert, right? Then we will have add. Then we will have some kind of thing, suggestion, get suggestion. We can have one more method like find word. In find word, what will happen is, let's say we need to iterate over this trie node and its children, and in the end we will check if is end of word is true or not, right? And this will help us in get suggestions as well. This is end of word true, is end of word variable. So now let's try to understand the different things that we can use, how we can proceed for the further implementation of the our LLD implementation. So now let's start with the entities. So as I already explained, TrieNode data structure, to store entities and to traverse them, it can have different methods that I explained, that we need to add it, we need to search it, we need to check if this prefix can have multiple suggestions. We can also add delete if we want, right? But we are not going to add it for now. Then for context, as we are creating autocomplete engine for IDE, for context we can take language for simplicity, as we need to code this in our interview. For now I will take language as an context variable inside our entity, TrieNode entity, which can have Java, Python, JavaScript, or many more other languages like HTML, right? Then we will create word entry that contains metadata and word related details. So when we are giving, when we are, this is going to be the main building block of our LLD. But when we are giving suggestions, let's say we need to give a list of suggestions, right? So for that list of suggestion, that means we need to give list of words. For that purpose, we need to create a class word entry that will store the all the words along with its metadata. Okay. Then we can have entity type. we can have entity type, which kind of entities we are going to store. This can be like in case of IDE, we can have keyword, we can have method, we can have variable, we can have class, and there can be multiple things that we can have, right? And method here each method here, let's say keyword, as one strategy that we need to use is frequency based strategy, how many times user is using a particular word. Based on that we can sort them. And other is relevance. So keywords are the main building block, so we can assign a relevance of 1 to keyword, like that is going to be most, we can give most priority to keywords. Like whenever we are adding a keyword, if we are searching anything, uh, if there are two suggestions, like let's say keyword and let's say method, we are going to give 0.9 relevance score. Okay, so let's say for a particular prefix we are going to get 2 keywords and 3 methods in suggestion. Then how the sorting is going to happen? So the first 2 suggestions will always going to be for keyword. That is because keyword we know is going to be used by our system. These are the basic building blocks. So there is most probably user is looking for applying a keyword or writing a keyword in the IDE when writing code, right? After that we will give the preference to method, that we will look when we will see the implementation. Then we can have rank strategies, what we have discussed above. It can have one method, rank entities, and available entities we need to pass, available entries we need to pass inside it, so that we can get a list of entries based on for a particular prefix that we are searching. And we can have frequency rank strategy, frequency based rank strategy, relevance based strategy. So frequency is nothing but how many times user is using a particular word, that we are going to uh, record the usage of record usage for each word. Whenever we are using a word in our IDE, then we need to have one call to record usage, which what it will do is whatever entries we have, let's say print we have, so how many times whenever user is using print, we need to update the usage count of that particular entity, right? That will help us. Then we will try to create AutoComplete Engine Facade class, which will interact with the data structure, WordEntry, entity type, rank strategies, and try to give us all the methods on high level that we can use. Let's say get suggestions, add word, record usage, these kind of things we can do. Okay, now let's try to deep dive more in the entity fields that we can have. So in the TrieNode, we will have these things, these fields. One is children, that I already discussed. These two fields is end of word and children. Children is nothing but a map, hash map we can take, or concurrent hash map if we want to scale it. Usage count, this is required. We have added this variable only to get frequency strategy, right? Then we have word entity type. This is the enum. Word entity type and language. For context, we have taken this variable. We can consider these 3 or 4 words as metadata. For this, we will store these variable values in our word entry class as well. Word entity type, language usage count, and we will increment usage count based on the how many times we are using this TrieNode flow path that we have discussed, like print, how many times we are traversing print, how many times we are traversing println and private. At that point of time, when we are marking any node is end of word, then we need to set the word variable as well, that whole word, what word it has created till now. Like when we are writing print at t, we are marking is end of word, then all the characters that we have gathered till now, that will add up and create a word print, right? Entity type we already discussed, and then it will have methods. As we have created this trie data structure, it will have insert word, find word, get suggestion, delete suggestion, or it can have one more method like find prefix, right? Word entry, this we have discussed. Now we will have the autocomplete engine. Ranking strategy, I've already discussed that we will have one rank strategy interface in, and we are going to implement based on frequency and relevance. So there are going to be frequency based rank strategy which will implement this method, these are going to implement. And who is going to manage all these classes? That is going to be autocomplete engine. This is the facade class that we will have, that will contain the TrieNode rank strategy. Here we can define our which rank strategy we want to use, current language. For context, we can use, if we are using Java, let's say we are defining our engine for Java language, right? So we can define our Java language and all the things that we are going to store in the TrieNode. Every TrieNode variable is going to have, every node of TrieNode is going to have language set as Java. If we are storing inside our engine, marking it as, right? Then it can have multiple methods which will internally call TrieNode, addWord, suggest. This will give us list of word entry. Okay, record usage. This method is used to increment the counter of usage count. We have usage count variable, right? And this will help us when we will increase the counter, and when we are in our frequency based strategy, when we are searching our entry in a sorted order, in that case we will use that variable to compare, and if the value is higher, then that word entry is going to be come on top. Then we can also initialize language. So now we have completed the data structure part, we have completed the understanding of entities. Now let's try to move to the UML diagram of this problem. So here we can see the UML diagram. So let's try to understand TrieNode class. As I already mentioned, it will have children and is end of word, this map, and this is a boolean variable. Then we have usage count. So I have taken this as integer, but for thread safety, we will take it as atomic integer. Okay, then we will have word, which can be marked as word or not. Based on this flag, we will have taken this. Entity type is a enum that we can see here. For now, I've simplicity, I've taken few keywords like keyword, method, variable, class, and I've also assigned them relevance score. Keyword is going to have highest priority, method will have lesser, variable will have lesser, and class will have more than variable. We can also add some more enum variables inside it, but for now I have added few more in the implementation, 1-2 more based on the usage. This is going to be entity type, and then language we can use Java, JavaScript, Python, Go, or any other language. Then it will have getters and setters, and then there are going to be some important methods like insert. What we are going to insert, we will have one word, we need to provide which kind of entity type it will be inserted. So when we are inserting our node, we will assign this entity type here and language as well to get a better context out of it. Then we can search a word, right? And then we can have few more methods. Maybe we will not use it. Start with get suggestion. So we have created two get suggestion method. One is by passing the string, and in other one we are passing language as well, so that it will give us only specific results to that particular language. If that word does not belongs in that language, then we will not get that suggestion. So to uh, why this context is required, language context is required, because when we are using a particular language, we want to know only related to suggestion related to that language, not related to other languages. Like how we define methods in uh, Python is using def keyword, def, right? That suggestion we do not require when we type de in the Java, when we are writing a Java program, right? So that's why we need to create get suggestions. Then we can have find node, collect words. This is these are some methods that we will utilize inside these methods, inside these 5 methods. Okay, so these are the things. Then when we need to, as when we try to get suggestion and we will get result from TrieNode, we will try to map it to WordEntry class. So whatever value we are getting in word and entry type, language and usage count, we will try to map it directly to this class and return this to the user. Okay, then we will have ranking strategy that will have one method, rank. So it will take a list of entries on which it will rank, right? And then only it will able to return. We need to provide an input to it, ranking strategy, and a prefix string. Let's say we have all the entries, but we want to search pri, so it will check inside it, right? So there are two implementation: frequency strategy and relevance strategy. These are some internal methods that we have created to override this particular method of this interface ranking strategy. And then we created a facade class that will have that will try to use this ranking strategy, TrieNode, WordEntry, and EntityType. So this engine is responsible, like user will call or admin or our IDE will use this engine to where our TrieNode root is defined, which will check all the suggestions for word entry. Ranking strategy we can define dynamically when we will create the object of this class. Then we can have a context history, like in which language we are using. I just added one variable. It might not be mandatory as part of interview process, but and current language, which language we are using. For that current language, we can initialize language method also inside it. We have the some of the constructors. Then we can have set language context. We can have addWord, suggest. This addWord will eventually go to TrieNode insert word, right? addWord will call this. Suggest will call the get suggestions. recordUsage will call the will increment the usage counter for that particular word, and get context history I've added. So now if we see, it has one facade class which will call the TrieNode, WordEntry, and there are few methods. In ranking strategy, we need to see what is the logic to calculate the frequency. That is generally based on the usage counter. So we will try to sort based on the usage count for a particular word. In relevance strategy, we will check the entity type of that particular word, and based on that we will try to rank it based on the relevance. If the entity type is keyword, then it will get higher preference than the method, variable, classes. That's how. Now as we have completed the UML diagram and understanding of the problem, understanding of the data structure that we are going to use. Now let's try to move to the coding part. So here we have defined the TrieNode class, which will have children in it, is end of word, usage count, and these are the metadata fields. I think this we can add it here for our engine, and these usage count, word, entry type, and language we will map to WordEntry field. See, this has 4 fields. These are metadata fields that we have inside TrieNode, and we will try to map it when we try to create a word entry for each word when we are returning our suggestions. So here we have getters and setters for this, and then we have insert method. So how we are going to insert inside our tree node? Let's say we will take this node. We will try to convert this word in array of characters, okay, and then we will try to go from one character to another. Then current get children. This is a hash map, right? So it will have inside this we can put the character. If it is not present, we will if it is not there, let's say we are starting our autocomplete engine, then we need to when we need to insert it every character inside it initially, right? Let's say we have print, so first p will go, right? And then we will try to map it with new try node, and then for second character r, again it will have we will put it, and then we will assign the same for second node. We will get the node of reference of p. For r we will get the reference of p. For I we will get the reference of r. Then only we will able to, that's why we are assigning the get character. We are doing get call and then assigning the node, assigning the node based on the character that we have given. And after it has iterated over the whole word print, then it will set current set of word, set end of word as true, set word, the word that we have passed, set entry type that we have passed, set language, language that we have passed. Similarly, we can search a word inside it. How we can search it? We can call a method find node, and this will also try to check get inside this hash map. Let's see find node what it is doing. So it is just pointing it to the same try node, and then we are iterating over the array, word array, and then it is checking if get children contains key. If it does not contain, then we are not able to find node, right? If p does not present here for print, then we need to return null because there is no node. Or if pr is there but we are searching a word, then it will try to give reference. What is the reason if we have only added pr inside this? Okay, and then we will check if for search if it exists or not. Then we need to check node is not null and node is end of word. This variable is true or not, right? If it is true and we have searched it, then we need to increment its usage counter. That can be helped. That can help our system to understand the frequency of this word. And we can have get suggestions where we will get prefix. For this, we will create a suggestions array list. Okay, and we will try to search find node. So this is the same method that we discussed. If even if it is not able to find till last, right, it will give the most recent child, the last child that is present in our system, so that based on that we can based on the current node that we have provided, we can collect words. So what this collect words, we are passing the prefix node with that we have got using the find node method, and prefix and suggestion array list. So in this method, we will check if it is end of word, if the node that we have got is end of word, that means that particular prefix. Let's take an example. If we are giving prefix as print, then one suggestion is directly going to be of print because this is directly a word. But if we have given pri as prefix, then this condition will not hold true initially. It is not going to be the end of word. Then what we need to do is we need to iterate over the TrieNode entry, like every get children and entry set, right? So inside that we have used the recursion. We will again try to provide for each entry, we will try to get value. Get value means character, and then we will add the current word plus get key inside it. Okay, so it will call this same method using recursion, and whenever we get is end of word, we are going to suggestion.add. So whenever a word is completed, then only it will become part of suggestion and suggestion class. And here we are creating a new word entry class which will just have the current word name, and the node that we have passed, it will try to get entity type, language, and usage count. Okay, this is how it is used. Similarly, we can have one more method for language where we will filter out all the values if those belongs to the same language, right, based on the language field. Then we can have find node, we can have collect word. So that's what we have discussed the entity type. We have discussed the TrieNode, WordEntry, and EntityType keyword. So I have added one relevance score, one variable, find double relevance score. Based on that, relevance strategy will also work. So now let's try to jump into the ranking strategy. So it will return a list of words when we call it rank, and then what we need to provide in the parameters, we need to provide all the entries that are present in our system and the prefix words that we are searching. Okay, then we have frequency based strategy. So what is the frequency based strategy? We will have all the entities, then we will try to sort it using comparator, comparing integer value using the get usage count. Okay, word entry get usage count dot reverse, and we will also reverse it because it will reverse from uh, in ascending order, but we want it in descending order. Okay, then comparing, and then we can compare the words also alphabetical way, and then we will convert it to list and return it. Let's see how relevance strategy works. Inside this we will calculate the relevance score. So what is the relevance score? How we can calculate the relevance score? Let's see in our comparator. Before that we need to calculate it. So for entry type we will check the entry type. If it is not null, then we will try to get the relevance score. If it is a method, we will get 1. If it has, let's say, we have a different relevance score for each kind of enum that we have added. So I've added one package, one variable, class, and these are things. Package has least relevance score. So but if for a particular entity we have not provided, we are just taking a default value 0.5 as the relevance score, and we have just added usage bonus based on this. This is just optional, we can return this part only, but if someone is using relevance strategy, then this method can be added, which will just increase its little bit of chance get usage count. Based on the usage count, we are adding that inside the relevance as well, and then we are passing both. So this strategy is also using some kind of usage count value, although that we are multiplying it with 0.01, so it has very less significance. Okay, so now we have done. Now let's with all the entities and strategies, now let's try to understand the autocomplete engine. Okay, so autocomplete engine will have TrieNode root, ranking strategy, context tree. This can search patterns by language and current language. So when we are defining the autocomplete engine, this will try to, if we are just using default constructor, then current language will be null. Okay, we can, there is one method initialize language, inside which we can, if we are passing the language Java, then it will initialize Java method call. So these are some sample methods that I have created. This we will not able to create in interview because we will have less time to code, but we can mention it to the interviewer uh, when we are using language Java, right? So our search engine will not start from the zero, right? Keywords are those words that are the building blocks or of any language. So those keywords should be added when we start our engine, right? We do not need to add. When we are adding it, we should be adding some method names, some variables, some values, or some text in it. But these values should be added when we initialize our engine, right? So public, private, we are all aware that these are the keywords that are in the Java language: abstract, implements, byte, char, switch, throws, return. And what we have done is we just call the method addWord with the entity type keyword and language Java. Similarly, we have done some for basic methods, for some classes. Okay. Similarly, we have done it for Python, like def for defining method. Then we have import while as these are same. Okay, similarly we have done it for JavaScript where we have where. So this part is just to show the demo, and then we have some methods to get the suggest word, which will call the record search first, and it will check the it will call the get suggestion inside the root node, right? And based on that we will get the suggestion list, and based on the suggestion what we have got from the our TrieNode, we can use the ranking strategy to rank the suggestion. These will be what we need to pass it as parameter, and then we will again get a list of we can say sorted based on the strategy that we have provided, that we have defined. And then we can also limit it based on the max results. Let's say for a particular word we are getting 100 of suggestion, but we will not show every word to user, so there is going to be default limit how many suggestion max we can use max. So that is what we have used this variable for. So now for record suggestion, record search, we can search it. Now our whole implementation is completed. Now let's try to uh, run our code. This will have pre-populated data, like I created some methods which will try to demonstrate different strategies, different contexts, and different usage. Okay, so let's see frequency based ranking. Let's say we are suggesting for P. So if we go inside it, what we are doing is we are taking suggestions for word P, character P. So these are the suggestions that we are getting. Okay, for the we are initializing it for Java here, so that's why we are getting for Java. And then we are adding some words, then we are suggesting, and what we have done is here we are getting in this manner. Then we have added the record usage. Let's say in my IDE I have used private word 2 times, println 1 time, so it will increase the counter of this word. If we go inside it, it is just go inside search and see here it is incrementing the counter, which will help us in the frequency strategy. So when we try to suggest it again, so what we got first is package, but because we have increased the usage of increase the counter of word private, then private should come on top, then println, because that also has one usage, and then package on third time. So this is how frequency based ranking work. Then we have relevance based ranking, suggestion for C, keyword first. So it is giving a keyword to us first, because keywords has the maximum relevance score, right? Continue, catch, class. So these are the keywords. Then we have class, case, character. Okay. Context learning. For Java context, we are suggesting a suggestion for CL, and we are getting clear. For Python context, we are getting nothing in return, and for JavaScript context for CL, we are getting class. Context history we can also search, as we have created one variable context history here for usage tracking. Initial suggestion that we got for usage tracking, let's see where we have usage tracking. So in this we are adding the word. These are extra words that are not added initially when we initialize our uh, Java language, and we added some of the keywords, methods, and classes, right? So we are adding some words, process order, process payment, and we are calling it as method and the language as Java. So we're recording the usage of process payment 3 times. That is what we are doing. Process payment, we are doing it 3 times, and then we are suggesting for proc after that. Okay. So this is how the demo of this application works. I have also created one more class for interactive demo. So this I have created, like this is such a long class, but I've created using the GitHub Copilot. We can run it and we can understand it better. So here it is looking for which ranking strategy we need to use. So we can type one here. Then it is asking to initialize language from Java, Python, JavaScript, or we can also skip it. So let's say Java for now. Now it is giving what we can do. Now let's type suggest. Let me try to do suggest PRI. It is asking how many entries we want in suggestion. Let's say default is 10. 10 we are passing. So suggestion we got for PRI, print, println, private. We can also record usage. Let's say we, after suggestion we have used private, right? So we can type 3 here. This is just for demo purpose. We will not able to do this much in our interview. So we have recorded usage. Now if I again try to search it, suggest PRI, then private will has the higher rank. See, private is coming before the print. So this is frequency based. Similarly, we can have uh, related to that. Now we can give third println. We have used println, so let's give it to that. Now if I again try to suggest PRI, then see, private has come above print. We can add a word as well, add hello. Now it will ask for keyword method variable. Let me select 3 variable, enter language, we can use Java. Now it will try to create a node variable, so it will require all these values, entity type, language that we are using. Now if we try to search HEL, it will give us hello. Let's say I will try to type, let me add one more word, help. It will again check. Let me try to put it inside a method. Okay, and in Java language only. Then we can have and if we try to search suggest HEL, now we will get 2 responses. Let's say we are selecting 5. So we are getting help and hello. Now if we try to add the same thing, if we try to increase record usage, then their sorting will be changed. So I hope you understand this problem completely. Autocomplete engine for IDE and LLD. So if you have liked this problem, or if you want to see the code of this problem, then please subscribe to my channel and like and share this video with your friends. Thanks for watching.